Hello. Now we have to find the ratio between the two types of areas that are shown in this particular figure. So in order to do that, how we will go about it is first of all, we will name this A, B, C, D, E, F to avoid confusion later on. So this is A, B, C, D, E, F, right? Now let us see what are the angles. So again, for angles, we know that the angles of a regular, not even a regular polygon, for any polygon, the summation of all the internal angles comes out to be n minus 2 into 180 degree. So in this case, we are just looking at the hexagon here. So this is the enclosed hexagon, right? Now for this particular hexagon, we can say that internal angles summation would be 6 minus 2 into 180 degree. Okay, now this comes out to be 720 degree. Now because it is a regular hexagon, any internal angle, okay, that will come out to be 720 degree by 6, that is 120 degree. Okay, now that we have it, we know that this particular angle is 120 degree and this is also 120 degree. Okay, now just look at this particular triangle that we will highlight here. Okay, this particular triangle. What is this particular triangle? This is an isosceles triangle, right? Isosceles means at least two of its sides are equal. So this side and this side, this will be equal, right? So what about this angle? That is DCE, or in fact DEC. Both of these will be equal, and any of these would be equal to 180 minus 120 by 2, right? So this is 30 degree. Okay, all right, so this is 30 degree. This particular angle is 30 degree. So what is this particular angle? This particular angle is obviously 120 minus 30, which will come out to be 90, right? Because we know that DEF, that is DEF, right? DEF, that angle is also 120 degree from here. Okay, now this is 90, so that means this is 90 degree. And what about this angle? This angle would also be 120 degree. So this must be 60 degree, right? Because the whole thing is 180 degree. This whole thing is 180 degree, right? So this is 60 degree. Now obviously this is 30 degree. Okay, now we have all the angles at our disposal. So first of all, this is 30 degree, this is 90 degree. Now we have to find out the area of the orange one. So because it is ratio, we will take everything to be unit, right? This is unit, all the sides to be unit. Now because all of them are unit, what is this side? This particular side, this must be 1 by tan 30, right? Because this particular angle is 30 degree. Now this comes out to be root 3. Okay, so this is root 3. Okay, now the orange area, what is the orange area? Orange area must be half into base. This is a triangle, right? So base is root 3 and height is 1, so that is root 3 by 2. Okay, any confusion? No. All right, now what is the area of this whole hexagon? Now I have already linked a video how to find the area of a regular hexagon. It comes out to be 3 root 3 by 2. Okay, the answer. So this is the hexagon area. All right, for a unit hexagon. I will link. I have already linked that. And now what is the ratio? So ratio would come out to be 3 root 3 by 2. And what is the other one? Root 3 by 2, right? So root 3 by 2, right? So it comes out to be 3. All right, this is how you solve this. See you later in another video.